Okay, so we have the problem explained in the email. So I'm just going to go ahead and just draw the forces involved in this problem. Okay, so we have a normal force right here that's going perpendicular to the surface. Then we have the force of gravity pulling down on the 36 kilogram block. And then we have the force that the girl is pulling on the 36 kilogram block. So let's go ahead and just make this our x-axis and then this our y-axis. And we can see right here that just make this the 40 degrees that they explain in the problem. And then we're just going to go ahead and make this the Fy component of the force and then the Fx component. And then we're just going to go ahead and we know that a 36 kilogram block times 9.8, the force of gravity, is going to equal 352.8 newtons, which is the force pulling down. Now let's go ahead and just worry about the components. For the x components, we know that 65 times the cosine of 40 will give us this x, and that'll equal 49.8 newtons. Now, we know that for y, 65 times the sine of 40 will give us this component, which is 41.8 newtons. Now, since we're looking for the force on this object, we have two y's. We have the force from the girl pulling, and we also have gravity that's affecting that force. So we know that the normal force plus the force she's pulling on, that y component, minus the force of gravity is going to equal 0. So we're going to go ahead and we're just going to move F and mg to the other side of the equation. We end up with the force of the normal force equals force of gravity minus F. Okay, now we have mg, which is this that we solved for right here, and we have the force of the y component, which is just this right here. So we're going to go ahead and just say that 352.8 newtons minus this y component, 65 sine of 40, equals 311 newtons. Now, let's say they give you the frictional force, which is in the problem. I mean, not the frictional force. They give you the coefficient of friction. We know that kinetic friction equals the coefficient of friction times the normal force. Now we have the normal force and we have the coefficient of friction, so we're just going to multiply those together to get this kinetic friction. So that's what we have here. Now let's say they want the acceleration of the object. So we know that force equals the mass times the acceleration. So just doing a little bit of algebra, we know that A equals F over m. Now, this sigma is going to stand for that there is a change. There's a force you have to overcome in order to accelerate, and this is going to affect the acceleration. So we know that the acceleration equals the x component, because it's moving sideways, the x component right here, equals 65 cosine of 40 minus this frictional force, because this is the force that it takes to actually move the object. So in order, the acceleration isn't just going to be the x component, it's going to be that minus this force that it has to overcome over the mass of the object, which is 36 kilograms. So when you solve that, you end up with the acceleration equals 0.260 meters per second squared, and that's how you solve this problem.